guide for individual students in the real world. Also, it can provide the supplementary material and the hint in the right place and at the right time. More importantly, it can motivate the student to learn in the real world. However, we also find some problem. Okay. We find that to engage students in higher order thinking, more effective learning support or knowledge construction tools are needed. So in recent study, we try to lead in my tools for M-learning and U-learning activity. Okay, Jonathan said that my tool is a computer program that engages students or learners in constructive higher order critical thinking about the subject they are studying. So in this study, we try to use two kinds of my tools. The first is the grid-based my tool. We call it rapid grid. Okay, it is a logic-based construction method for developing expert systems, and now we use this method to help students identify and differentiate a set of learning targets based on the feature of the target. The second my tool is a concept map. It is used to help the student to organize their knowledge obtained in the field and their prior knowledge learned from the textbook. So this slide shows an example of the vector grid. Okay, it looks like a matrix or look like a table, and there are 4 elements here, and each element represent the target to be identified or concept to be learned, and there are 3 traits here, and the opposite of the trait, and the trait is used to identify the learning targets. Okay, and usually a 5 scale rating scheme is used to represent the relationship between the element and the trait. For example, in this case, golden Chinese bayang is 1. 1 means is likely to the leaf shape of golden Chinese bayang is likely to be long and thin. Okay, and 5 means the leaf shape of Indian almond is likely to be flat and round. So we use vector grid in a U-learning activity to support the student with a 2-stage approach. In the first stage, we ask the teacher to create an objective vector grid. In the second stage, we use the objective vector grid to help students develop their own vector grid. And this slide shows how we do that. Okay, this is the objective vector grid provided by the teacher, and this is the incomplete vector grid. Okay, it has an element and has a trait, but it's empty inside. So the student need to observe those planes in the field and to collect data to complete this vector grid. The system will guide the student to complete step by step. If the student correctly fill in the value, for example, in this case, the teacher's observation is land grass. The leaf shape of land grass is long and thin. Okay, it's 1, and the student also the observation of the student is also 1. Then okay, it's fine. And the learning system will ask the student to give more detailed description about his observation. However, if the student fails to give the correct answer, the student fill in a 4. 4 means the leaf shape of land grass is flat and round. In this case, the system will try to find another plant in this grid. In this, for example, it's a Indian animal. In this case, the teacher's answer is 4. Okay, so this is the correct answer, and this 4 is the incorrect answer to the student give it. So the system will ask the student to observe the leaf shape of these 2 plants in the field to make comparison, and then ask him to re-answer the question. I mean, the student maybe then find Oh. So to evaluate the effectiveness of the approach, we have conducted an experiment, and the subject is knowing the plan on school campus. Or you say you don't have such subject, okay? In a natural science course, and we try to compare two e-learning groups, one with the my tool and one without the my tool. So the subjects are 61 fifth grader, and in the control group there are 29 students learn with a conventional tool-based e-learning system, and in the experimental group there are 32 students learn with the my tool-based e-learning approach. And this is part of the finding. We have a pre-test and a post-test, and from the pre-test and post-test, we find that the use of my tool in e-learning activity is helpful to a student. Also, we have a follow-up activity. In this activity, we let the student determine the trait to be used to identify the learning target. Also, after the field trip, the student can go back to the computer classroom to share their finding to peers. Okay. I need to skip the result. Okay. We don't have time to say the detail. Also, the second concept map, the second my tool is the concept map. I just want to use a video to show you. Okay, and that will make you happy. I think so. Okay. So, how can a concept map be used as a my tool for e-learning? First, the students develop their concept map based on what they have learned from the textbook in the classroom. Okay, that's the original version, the first version of their concept map. And then they go to field. And then they go to field, make the observation to see what they have learned, to see what there's any difference between what they have learned and what they have observed. So if they find something interesting or something different, they can make the modification in the field. Alternatively, they can also take some notes and then go back to the classroom to make the modification. So I want to show you a 3-minute video.
The students are practicing to observe multiplying college and multiplying if you are able to come and compare that with what happened in the real world environment. Based on the observations, they can be involved with us by acting with the political objects or relationships between objects while used. Face-to-face research and the display request collaboration computers. In addition, they observe the ability to choose and observe the pictures in relevant contexts to can create an impression. It is interesting to find out in which learning stage the students may significantly complement our psychology to someone. Real-world observation with contact access on tools has enabled students to observe and control ecology and to have significantly better learning achievement. 我觉得使用 PPA 在很方便，因为它是轻手操作，印象比较深刻，我印象比较深刻。比老师上课还要深刻，因为啊，里面是有很多资料，你那边讲一讲，可能会就是说。那我在上课的时候是我们在那上面带过，然后今天就看那个猫后面的画那些东西，然后想要去熟悉之后，然后现场，可是现场跟我们的课程内容不是一样的。那可能在课程我们在上课过程当中讲的东西，没有办法说在实地面他们会理解啊。第二个好处在于他可以做一个连接动作啊，所以他看到的东西会比较。 the students can be assessed into results. Reading time use contact as modules in context of the reliability learning, not only enhances learning motivation, but also improves learning achievements after periods. Therefore, it is important to apply this innovative approach to learning activities in the future.
Okay, so this is the interface of the learning system. Okay, the student can modify the concept in the field, or they can take notes with this interface and then go back to make the modification. And in the following, I should show you some very quick. I can show you a different application of U-learning and learning. And this one is for a complex experiment procedure. Okay. It is called the single crystal X-ray diffraction procedure in a chemistry course. Okay, and it is the most effective method for analyzing 3D structure of compound materials. And the learners are usually graduate or PhD student in chemistry or material department, and it's time-consuming to train a new researcher. Usually, maybe 6 months to 1 year is needed to let the new researcher familiar with the whole process of the experimental procedure, and the operation could be dangerous. Okay, dangerous to the machine. Okay, the machine is very, very expensive, so they are afraid of that the student will break the machine. So usually the learner require full-time guidance during the training process. So we developed an U-learning environment with an expert system. We put the experimental researchers' knowledge into the expert system, and then we use a PDA to guide the student in that building to go around 3 stages in the 3 rooms to complete the procedure. In the first stage, the student need to learn to select a crystal of good quality and suitable size through the optical microscope, and mount the scope on the top of the glass fiber. Okay, so the expert center will check if the procedure, if this step is correctly performed. Okay, and then in the second stage, the student need to put the selected crystal into this machine to operate the X-ray diffractometer to find the cell constraint with a set deviation. And this step is also dangerous and complex, okay, because this machine is expensive. And the third stage is to use a program, special program to determine the 3D structure of the crystal line. Use it, okay. So this equipment are located in different rooms. So you must pass one stage, and then he or she can go to next stage. So the finding is from the we compare 5 researchers, since there are not so many researchers there, so we can only compare 5 researchers who use our approach and the 5 researchers who use the traditional approach, and we find that the number of mistakes made per experiment can be significantly reduced. Also, the average time need to deal with the faults in the experiment is also significantly reduced. And most importantly, the total time to fully understand the operating procedure is reduced, decreased from 5 months to 2 months. Okay. So now I want to dig even quicker to show you more application of learning. Okay, this is for local cultural courses. Okay, in the local cultural courses, the objective is to teach the student to love the ancient asset and to love the local culture. Okay, so in traditional approach, the teacher teach the student in this way. As you can see from this small photo, the teacher carry a portable speaker, okay, with microphone, and and bring the student to the in front of the temple. That's the learning object, okay? And then he yelled to the student, "Be quiet, right? And listen to me. We should love the ancient asset, okay? We should love this temple." The student, but no one listened to her, okay? And they keep chatting, they keep fooling around, and then the teacher become very angry, and then he starts scolding the student, and then everyone is not happy, and then they go back to the school. Okay, that's what happened all the time. So we decided to develop a learning system to help the teacher. Okay, so this is what we have done. Okay. With the help of the learning system, the system will try to guide the student to observe each target learning object with a background story. For example, in this, when the student is observing this pillar, the system will tell them why this dragon, this dragon on the pillar, why the dragon have only 3 crowns? Why not 5 crowns? Why? Okay, he will explain that because only the good for the king can have dragon with 5 crowns. But this is only a temple, not belong to the king, so it can only have 3 crowns or 4 crowns. Okay, he will tell every detail to the student. Also, the system will try to guide the student to read the ancient record on those learning targets. For example, in this wall, there are some ancient words on it. Okay, you will try to ask the student, what does that mean? Also, you will give some learning tests to the student and ask them to find a supplementary material from the internet. And finally, it will guide the student to touch something touchable. Okay, not everything. You cannot touch the statue of the god. Okay, for example, this drum is made of stone. Why it is made of stone? What it is used for? Okay. So after we use the e-learning approach, we find that the student become very interested in this local cultural courses, and when they give feedback to a student, to a teacher, they say that, okay, I really love local culture. I really feel that we should precious those ancient assets. Okay, that's a good result. Okay. We also have some application for nursing, for nurse education. Okay. In this photo, the learning system is guide the nursing school student to interview the patient and record the patient's health status. And in each year, we have more than 1,500 students participated in our learning activities. So I would also like to show you an ongoing project. Okay. It is an inquiry-based learning activity in the Chigu Ecology Park in southern Taiwan. In this area, there are black spoonbill, fiddler crab, and mangroves. And the students are equipped with a smartphone or PDA, a mobile device, and a telescope because they need to watch the bird. Okay, and also a set of probing device. For example, they need to collect data about the pH value of the water. They need to collect many different data. Okay. And then they need to build an ecology database for the target area. Not yet. So I want to show you a 3-minute video. Well,
outdoor observations provide students an excellent opportunity to directly experience the richness of nature. Through physical involvement, observation activities play a fundamental role for cultivating scientific investigation competence. In traditional in-field activities, most elementary school students can only work with very naive inquiry problems. With the rapid development of wireless communication and mobile handheld devices, the ubiquitous learning in authentic settings is attracting more researchers' attention. With the advantages of portability and easy information access, the mobile device application is a growing trend in the technology-integrated education era. Many scientists and philosophers of science emphasize that asking questions is relevant to the abilities of problem solving and the ambition of progress in science. Learning to ask data-based or scientific questions is very crucial for science education, since problems are considered as being one of the key elements of problem-based learning, PBL, an integral part of meaningful learning and scientific inquiry. We especially focus on the supporting functions for students to form their scientific problems. Via the provision of online support for in-field problem-based learning, PBL, the students are more likely to work with advanced inquiry problems. A designing model for developing ubiquitous PBL system, UBLS, is proposed for helping students turn their intuitive problems into database inquiry plans. The system developed in this study provides a discussion platform, e-library, and an ecology measurement database for the collaborative inquiry community. We attempt to provide friendly resources to students. It is expected that teachers and peers can be both moderators and responders. Moreover, rich learning resources can increase the collaboration of peers. We hope that by applying technology, outdoor observation learning activities can effectively help students to know and to care about nature. Future directions. The results suggest that the designing model of UPBLS is reasonably supported. The ubiquitous technology seems enjoyable and helpful for most of our participants. The system developed in this study is workable for elementary school students to form a collaborative inquiry community. The Green Lab system is crucial for students to develop data-driven thinking. The two groups' learning profiles presented also demonstrate that the problem-refining model is appropriate for our participants. Learning with UPBLS, students are well supported to refine their intuitively interesting questions to more data-based scientific questions. Based upon the promising research results from a stable and effective learning system, our research proposed to extend how research themes other aspects of ecology, inquiry, competencies. We also like to invite more collaborative partners from different expertise to expand this research community.
Okay. So as you can see from the video, we did not cook the crab, right? Okay. We just want to let you know that we after the learning activity, we let the crab go. Okay. 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 So now I want to make a conclusion. I think I concluded so well. Okay. I think that the popularity of those new technology have brought us a new aspect for perceiving education. So there are many new issues can be investigated. There are many research can be conducted. Okay. So it is also worth to re-examine and redefine many e-learning issues, as I have said, such as TAM models or personalization models in this new learning environment. And also new learning strategy or tool can be developed. Okay. And many people asking, why can you do so many applications? I think because I cooperate with other people. I'm, as you can see from what I have introduced by Kim Suga, I'm of computer science background, but I cooperate with educational technology background researchers. Okay, I think that's why I can do such the research. So if you are if you are interested in my study or you are interested in cooperate with me, I would be very happy. Okay, so if you are interested in what I just talked about, I have listed the relevant paper in here, about 30 paper. Okay, so you can get and read the paper. Okay. Thank you.
In presence of all these things, videos and so on, how does the classroom complement the regular things? What is the role of the classroom?
What's the role of the classroom? Okay. In fact, the all of learning activity is part of the existing curriculum. Okay, and they used to use the traditional way. Just teacher bring a group of students go to field to make observation. So we did not change the way they teach or change their learning content. We just use technology to support them to do the original learning activity and to make the effect of the activity better. That's what we try to do. So we did not create a new content or new activity. Yes.
Do you think that is expensive?
Expensive? You mean the device? The cost effectiveness. Yes. Okay. And because in Taiwan we are trying to use mobile computer to replace the desktop computer, so I'm not sure if it is time cost. Okay.
They operate in
yeah. Okay. Oh, okay. Yes, that's a problem. Yes. Okay, thank you. Okay. As I have just said, what we try to do is to follow the original curriculum and then the original content design. So usually in the elementary school, for example, there's 18 weeks in a semester. They might need 4 weeks. They might have 4 weeks to go to field. That's part of the curriculum. Only maybe 4 weeks they need to go to field to make observation. So in the beginning, we support them. We borrow the mobile device to them for 4 weeks, and another program may be used by another school. Okay. Initially, we do that. Okay, and finally, they realize, okay, this mobile device is good. So some schools still to use their budget to buy their own mobile device. And they can use that in turn because maybe one class only need to use 4 weeks. So they can give another class to use another 4 weeks. That's what they are doing now. Okay. But eventually we hope that every student could have their own mobile device, but it takes time. Yes. I don't think we can do that. But United States already announced that they will do that within 5 years, right? I see the news. And Singapore already do that. I think Singapore is rich.
The methods which you're using are part of the classroom curriculum.
Yes.
So the teacher now has to learn to deal with the fact that the students have more control over their learning, and the teacher cannot teach traditionally anymore.
Yeah, I know.
So even kind of guidance or when you provide to the teachers, and how much is their guidance?
Okay, that depends on the need of the also we need the agreement from the teacher if we want to change the way of teaching. We need to discuss with the teacher and then have the agreement from the teacher first. Otherwise, the teacher might be very angry why you changing the way of teaching. Okay. So it takes some time to discuss that. But we have tried different strategies. I have said we use my tool. In the beginning, we let the teacher define the category, right? The student only collect data to fill in the category, and finally, in a follow-up activity, we persuade the teacher let the student do their own category. You only need to tell them which plan they need to observe, and they can determine their own track to identify the plan, and they can have a discussion. So we have tried that, and some teacher will agree our strategy, and eventually they will find out, okay, it's even better than their original approach. Okay, so we try to use a student-centered approach to replace a teacher-centered approach gradually, but not immediately.